I encourage you, take a visit to Durham sometime, read the town signboard on the website, and you find they are very proud of one thing. Their bishop in the 1200s, he had a problem to solve. Theologians, Theol, meaning God, logons, as in logic or logos, the people who had a word about God. Theo, logos, a God word. Well, he knew all about theology, but you see, he lived in an area where we dug up rocks eventually, where we used the coal. We need a new word, he said, the study of the rocks. God has told us about the study of himself. Now, what do we call the study of rocks? So he invented the concept, and there it is, proudly boasted about on the town website. Go to their web, check it out yourself. He's the inventor of the concept of geology, and it was a Christian bishop. Now, you wouldn't think that if you read through your geological books on the millions of years of layers, etc. I mean, let me start. Here's my last sample for this morning. Can you see this? Can you see the layers in it? Now, you and I call those strata. This is supposed to be nearly 1,000 million years old. And can you see the fossil in the top? Now, that's a fossil stromatolite. The funny thing is, stromatolite simply means layered thing. And it's in a rock full of layer, but we use the Greek and Latin words, it means the same. We call the other one strata, stroma, layered things. And they use millions of years these days, and no relationship to God at all. So in our subject, as we go through today, dealing with the history of things, as we look at me on how do layers form anyway, as we go to tomorrow and deal with the geologic column in depth, beginning, end, does it even have such a thing? Remember the rock I showed you first, the one with the stromatolite in it, right? Now, This is limestone. Now, the interesting thing about stromatolites is they're self-rocks. They form rocks anyway, and the stromatolites are still here, and they actually exude a limey glue. When we've made stalactites and stalagmites, we've discovered that you get leaves that will stick on the stalactite, and even bats and insects and flies, they'll land on it and they'll get stuck, because the organic lime plus bacteria actually makes a natural glue. So when you look at the layers in this one, the funny contradiction, of course, is the name of this means layered thing, but it's sitting in rock here, which is most likely simply made by the organism itself. So there's a question here, it's limestone, and it says, could we get another answer to the still repeated limestone argument that people argue it does not form in flood deposits? Now, I've seen limestone form just in our strata machine. I've seen limestone form in our fossil tank deposit, where we actually show you the trees standing upright and the calcium carbonate will fall out of solution. And you can see crystals of calcium carbonate forming on the spot. Vance Nelson, one of our colleagues in Canada, sent me the other day a metal cast, a pipe that comes from a hot water spring, and it's full of calcite crystals. It takes a maximum of 6 weeks for this pipe to clog up. It does not take a vast amount of time for limestone. The flow is following it's a catastrophic deposit, and yet the crystals are actually forming. So, Joe, you have lots of interesting limestone on the east coast there, and you and I have climbed all up and down the Cretaceous, the White Cliffs of Dover, etc. I've seen them all along the boundaries of the Mediterranean, right across to Turkey, photos of all of them there. So you're more experienced with some rather interesting limestone on the east coast of England.
Indeed, I've spent most of my life sitting on top of 1,000 feet of limestone. We have some of the deepest chalk and limestone deposits in the world, and we have a huge abundance of limestone and chalk here in the UK as well. So I'm very, very familiar with it. We've dealt with limestone many times before. Let me just give you a few interesting points. Number one, you've got to make sure you have a distinction. A common misnomer is that all limestone is made up of marine sea creatures. And the argument is you require a warm, shallow kind of marine environment, water environment, lagoon-like environment, where you get the planktonic blooms and the seashells and the creatures which slowly settle down, and over hundreds of thousands or millions of years, you build it up into a calcareous ooze, which over hundreds of thousands of millions more years, it compresses into chalk, right? Number one, the vast majority of chalk and limestone deposits in the UK are very, very pure, particularly the case of the White Cliffs of Dover, right? They're called that for a reason. So you don't have any indication there of vast ages of slow accumulation because they're really pure. They're up to 98 to 99% pure calcite, right? No grit, no muck, no ooze. Now, you do get some grey chalk formations where there's certainly muck and ooze and stuff that's kind of got caught up in it. Is that an indication of slow, gradual deposition? In fact, a lot of limestones are grey because of the contamination. Is that evidence of slow, gradual formation? Well, at that point, you then need to turn to the fossils, right? But the first thing to say is not all limestone is made up of marine fossils. You can get chemical limestone as well. In fact, calcium carbonate, the formation of it's a chemical equation. So you get quite a lot of limestone which has got no fossils in it whatsoever. It's purely a chemical solution, and you have examples of that forming very, very quickly today. In fact, one argument is that it has to form quickly if it's purely a chemical solution, and it has to form under flame. All right, for the ones that are fossiliferous, you can look at the fossils. What do the fossils indicate? I mean, the very presence of macrofossils. I mean, the vast majority of the chalk and limestone is made up of coccolithophores or foraminifera, which are tiny little sort of microscopic plankton, right? But you do get very, very large fossils buried in this chalk and limestone as well. Now, the very presence of the large macrofossils in the chalk and limestone is evidence that it was buried very quickly, because if you take hundreds of thousands or even millions of years, you'd never get a fossil, right? Time will destroy your creature long before it has time to turn into a fossil. Then you can look at the evidence of transportation. Transportation, have these creatures lived and died and settled in the one area and slowly been built up, or is there indication that they have been swept into position? So you can go and do research projects. I did a 3-month research project for university. My first paper published was on the evidence of transportation and rapid burial in the fossils of Hunstanton. We did other reports and research projects on the belemnites of Whitby. Right, belemnites are a squid-like creature. They're elongated. First year of geology, I was taught elongated things like trees or belemnites or shells. If they're pointing in the same way, you've got evidence of transportation. Water has flown through and swept these into position and has made them point in the same direction. You can run this experiment yourself. It's well established in geology. You can see it in the log jams of Jurassic Ark and everything else in between. One thing that we consistently found, and it's not just in the limestone deposits of the UK, it's around the world as well as we've traveled, is that up to 97% of all fossils showed evidence of transportation. That means that they were buried in flowing water. So therefore, this calcareous ooze that they're buried in before it got sort of chemically altered into what we would now refer to as limestone, it was buried in a great big slurry, flowing in one direction, sweeping the fossils along and burying it down as well. And by the way, yes, the dominant view in geology is that this is a slow, gradual process, but it's certainly not the only view. There are multiple publications now starting to come out in the scientific literature which talks about limestone being buried under flowing water. To give you one example, we've got a paper up in front of me from the Journal of Sedimentary Research, very prestigious paper, published in 2013. The observations we report, they say, suggest that published interpretations of ancient lime muds and derived Paleo-ocean geographic conditions will need to be re-evaluated, rethought. Why? Because observations from modern carbonate environments, that's limestone production, and from the rock record itself, that's looking at the rocks and the fossils, suggest that deposition of carbonate muds, that's your calcareous ooze, calcium carbonate is your limestone, by currents is likely common throughout geological history. That's not what you read when you go to your beach and you look at your signpost or you pick up your university textbook or high school textbook, but this is what's in the scientific literature. Similarly, conventional wisdom, by the way, conventional wisdom is Lyell and his principle of present is the key to the past, right? Uniformitarianism based off of Steno's superposition. Conventional wisdom about low energy requirements for shale and limestone deposition discouraged geologists from entertaining high energy alternatives for many years. It's therefore very possible that more carbonate muds will be interpreted as high energy deposits once the science behind the concept becomes established. In other words, calcium carbonate, limestone, chalk, whatever you want to call it, it has nothing to do with time. It has everything to do with the process. It can be a chemical process. It can be a water-based process mixed with a chemical process. But either way, no issue with fitting it into a large global flood with flowing waters and currents, particularly in light of the strata experiments that we've briefly talked about tonight. We go into the specifics and the flood geology tomorrow, so join us there.
Awesome. I'm looking forward to it.